Our project is an embroidery machine that runs on G-code. It was based on the project self-made embroidery machine running on G-code by James Colm. The purpose of this project was to create a prototype for a more affordable and portable embroidery machine that will be marketed to teenagers and college students wanting to make simple and refined alterations to their clothing. The project consists of a rig that is made up of 3D printed part and manufactured parts that are controlled using an Arduino Uno, an A4 9A8 CNC shield, and 3 DRV A825 stepper drivers. This setup controls 3 NEMA 17 motors that work in conjunction to move a 3D printed embroidery ring and place it under our modified sewing machine's needle, effectively mimicking the process of embroidering. The following video depicts one of our G-code test runs. We made our 3D printed parts using a Creality Ender 3 3D printer and used STL files that were provided by the creator of our reference project.
One of the important hardware components is the Arduino. We chose to use the Arduino Uno R3 to control the motor movement. This was done by putting a GRBL shield on top of it, which will take G-code and then change that into the motor movement. We also implemented a Raspberry Pi 4. We did this with the touchscreen. So you can draw your design, translate that into G-code, and then upload that to the Arduino to tell the motors which way to turn and how far to turn. The motors we used are stepper motors, NEMA 23 and NEMA 17. The NEMA 23 is used to control the Z-axis, that's the movement of the needle. And the NEMA 17 motors were used to control the X and Y axes, and that's the movement of the fabric underneath the needle. One of the main important parts of this is the stepper driver. The stepper driver controls the current that goes through the motors, but also how many steps or degrees those motors are able to turn. And the other important function is that it connects all the hardware together. And this can be shown in this picture right here.
Next up, we have the software. For our project to work, we had to use a couple different types of software. We needed to interface the Arduino with the CNC shield. We needed some type of user interface so that we could control and send code to the Arduino. Next, we needed to be able to create patterns and generate code from those patterns. So for the Arduino to work with the CNC shield, all we needed to do was download the open source software for the GRBL and send it to the Arduino. Next, we downloaded a GRBL panel user interface. It's pretty simple. You're able to jog each of the controls, X, Y, and Z directions, set a distance it will move, give it a feed rate. It does give feedback, which is great, the X, Y, and Z on the left side. And then you can upload a file, and then you send that code, and it'll run, and then that's how the stitching happens. This is right here is a universal G-code center. This is the actual G-code panel, GRBL panel that we ended up using. This is because our Raspberry Pi runs a Raspbian operating system, and this is the only one that we could find that worked with that. All right, so Inkscape is a powerful open source illustrating tool. You can create all kinds of patterns on this, pretty much any logo you can think of. We use Inkstitch extension to generate a stitching pattern that compiles into G-code. And here's some G-code. On the left side, we have some G-code for a star, and it's some 40,000 lines of code, which is a lot, and it takes a long time. And for us to test and calibrate how our embroidery machine was working, we ended up having to create our own G-code. It's pretty simple. You just have a command that says G0 send impulse, which is send impulse to X and Y location, and then move the needle, which is the Z axis, up and down. And just do that a bunch of times with each location, and you have your G-code.
While the product quality isn't what we had originally planned, it's still a great step forward for us. Through this project, we set ourselves on the right track to, in the future, produce the quality of machine that we desire. Thanks to what we learned in the fields of CNC machining, 3D printing, G-code, and microcontroller usage, the picture designs were made using handwritten G-code and the manual operation of the sewing machine. In the future, we aim to properly implement the use of our Z-axis motor, which controls the up and down bobbing of our needle, and that is synchronized to the movement of our ring. And that way we could produce the quality of designs that we want. Or we also want to implement the use of a G-code generator. We want to use Raspberry Pi so that people can design whatever they want on a touch screen and then send it to the machine and have it embroider it for them, or possibly include Bluetooth and a phone app where people can design their whatever they want on their phones and send it to the embroidery machine. And of course, we also want to minimize the design and make it something more portable and marketable. And the following video is our machine effectively running G-code. Thank you for your time, and I hope you enjoyed our project presentation.